Okay, so I'm going to show you another way to solve this circuit without redrawing everything and doing the process that I showed before. The only thing with this is it might be harder to find your mistakes if you make any. But basically, the first step would be to find the total resistance. So we want to find the equivalent resistance of the circuit. And so the equivalent resistance, we're going to use both the parallel and in series. So we just go around. We're doing the same thing, but we're going to do it all in one step. And so looking at this circuit, the first thing that we would have to do is do these in series. So R3 plus R4. So R3 plus R4, because those are in series. Oops, I wrote B plus R4. So that puts these two together. And then these two are in parallel with this one. So we have to do 1 over that. So 1 over this plus 1 over R2. And then we take the inverse of all of that. -1. So this right here, this piece, put these together in series, and then this whole thing, put these together. And then what's left is R1 plus all of this plus R5 because they're in series. So plus R1 plus R5. And then if we substitute our numbers, we get 1 over R3 and 4, so 14. 1 over 14 plus 1 over R2, which is 7. Take the inverse, plus R1, which is 5, and R5, which is 3. And then at this point, all of that can go straight into your calculator. And you get an equivalent resistance of 12.67 ohm. So that's the resistance of the entire circuit. And once we have the total resistance, then we can find the current out of the battery. So step 2, I from battery. And the current out of the battery is just going to be the EMF divided by the resistance, the total resistance. I'm going to put IB. So that would be 12 volts divided by 12.67. So you get 0.95-ish amps. Okay. So now what we've done is we put everything together and we found the current coming out right here. So the current out of the battery. And what I'm going to do is I'm going to write them in again. Delta V1. Hold on. Let me pause it. I'm going to write them in again so we can see that the quantities are the same. Okay, so the current, remember in series, it has to be the same. So we're going to have 0.95 across resistor 1. 0.95 amps. And then that current goes here and then it splits. So I don't know what the current is here, but I know that it comes back together and across resistor 5 is the same. So 0.95 amps. Okay, I don't know the current across 2, 3, or 4, so those have to remain the same. But since I know the resistance and the current now, I can go ahead and get the potential difference. And so if I divide this by this, I get that, 4.75. And same over here. If I multiply the resistance times the current, I get 2.85. Okay, so now we know the potential difference across this resistor and this resistor. So now I can see what's left. And that would be my potential difference from here to here. And whatever that value is the same across each of these resistors. Okay, so we start with 12 volts. And we're just going to take off the 4.75 volts minus the 2.85 volts. And we get 4.4 volts. So when it comes in here, from here to here is 4.4. And since these two sections are in parallel, the potential difference across R2 has to be 4.4. So we get 4.4 here volts. Now, since I have the resistance and the potential, I can get the current because we just divide them. So 4.4 divided by 7 gives me a current of 0.62. Well, 628, which is 0.63. And done. We're solved that one. Okay, now we can go back to the junction. So the current comes in, it's 0.95, and then it splits, and it's 0.63 on this side. So all I have to do is subtract, and that tells me the current through this side. So 0.95 minus 0.63, we get 0.32 going through this side. And that's what we have. That's what we had calculated before. So 0.32 comes this way. Since they're in series, they have to be the same. So both of these are 0.32. Now we have the current, we have the resistance, we can get the potential by multiplying, and we get the same. So 1.28 and 3.2. And we're done. So a little bit quicker, actually a lot quicker. You don't have to redraw. It's just applying these rules. So working carefully, making sure that you find the equivalent resistance to get the current from the battery, and then you go back and you just work with what you have, what you know, and what you can solve, and then everything else pops out. So hope that helps.